Hello and welcome to this video on graphing quadratic functions of the form f of x or y equals, and then you have the quantity x minus h, all of that x minus h is the base squared, right, to the exponent of 2. Here h represents just any real number, so like the quantity x minus 2 squared, or the quantity x plus 5, right, where h would be negative 5 minus a negative 5, right, plus 5 squared, x minus some number squared. So what we're going to be seeing here is another example of a function or a graph transformation. What we're going to be doing in this video is starting with a basic parabola, the basic y equals x squared, and then through a very simple change to the expression x squared, we can get an equation for a new graph that'll simply be the original shifted to the left or to the right however many units. Alright, so on my first page I'm going to discuss what does it mean to horizontally translate or horizontally shift a graph, and then I'll do a couple of examples where we're dealing with quadratic equations of the form mentioned here on this page. So let me begin. I'll start with talking about these function transformations, and this type here called horizontal translations or horizontal shifts. This is simply moving the graph up to the left or to the right on the coordinate plane, right, horizontally. Alright, so suppose we're given a graph. We're given the graph of y equals and then some function of x, some expression that depends on x. So say y equals x squared, or y equals 2x plus 5, or y equals the square root of x, or whatever. Y equals, this f of x just represents some expression that depends on the value of x. Well, what we can do is take the graph of this, right? I'm gonna put up a little makeshift coordinate plane off to the side. Suppose this is the xy coordinate plane, and I'll put in the green color, the graph of some function. Alright, so suppose, again, I'll just do like a little smiley, a little parabola looking shape. There's the graph of y equals f, right? Y equals f of x, say. Then with a very simple change to the expression, we're going to be able to make a new equation whose graph is simply the old graph, just move left or right, so many units. So if we're given the graph of y equals f of x, then the graph of y equals f of, and then inside the parentheses I'm going to be replacing the x in my original expression with x minus h, okay, where h is some real number. The graph of y equals f of x minus h is the graph of the original and there are two cases. One, if h is a positive number. So for instance, I replace all the x's in my original expression. I replace all the x's with, say, x minus 2 or x minus 10, x minus some positive number. What you're going to notice is the graph of this new equation will be the graph of the original, just shifted to the right h units. So if I did that here, if I replace x with x minus h, and h is positive, x minus 7, x minus 6, it'll be the same picture, just shifted to the right. So I'm drawing the same picture here. All right, again, this is a hand drawing, not perfect, but it has the same little smiley shape. It would be moved to the right. There's y equals f of, and then x is replaced by x minus h, where h is positive, right? It shifted right h units. The other case is, what if h is negative? Right? Say I replace my x in the original expression with x minus negative 5, which would be x plus 5, or replace x with x minus negative 3, which would be x plus 3. So if I replace x with x plus a number, which would be minus a negative number, then what's going to happen is the graph will shift to the left. Right? Our original graph will be shifted to the left. Now I'm going to say here the absolute value of h units, because here h is a negative number. So when I talk about moving a distance, usually distance is non-negative, so I throw the absolute value of h around that to make it not negative. All right, so again, here's the original graph, and if I replaced x in the original expression with x plus 1, it would move the original graph left 1, right? Because h would be negative 1. Or replace x with x plus 5, it would move the graph left 5, where h is negative 5, x minus negative 5. So it would be the same shape, right? Just shifted to the left. There's y equals f of x minus h, where h is less than 0, right? Okay, but the same shape, right? It looks exactly the way it is, just move to the left or to the right. Okay. All right. So really what you're essentially doing to all the points on the original graph is, if I replace x with x minus h, all you're doing to the original graph is adding h to the x coordinates, right? If h is positive and you add h, you're moving to the right. If this h is negative and you add h, that means you're subtracting, you're moving to the left. So really what you're doing here is adding h to all the x coordinates of the original graph. And that causes the transformation, that causes the movement. Okay, so let's look at a couple examples of this where we're working with strictly, this is for any function, the graph of any function here, this description of horizontal translations, horizontal shifts, but we're going to specifically today look at the graph of y equals x squared, right? The most basic quadratic function, a basic parabola. All right, let me pull this off and let's go to my graph paper here. I got my first example, and in both the examples I have the following instruction: use the graph of y equals x squared. Right, so we're going to start with that graph and graph the quadratic function here. F of x, again, or y, if you like having y, remember f of x is just the output, the y coordinate. So graph y equals, and then x plus 5 squared, right, instead of x squared. So you see here, x is replaced by x plus 5. Now what I'm going to do is I'm going to draw both of them. And we're going to draw y equals x squared, and also y equals this x plus 5 quantity squared. But what we're going to see here, notice that x in the original expression was replaced by x plus 5. So x is replaced, right, in the original expression. X is replaced by the quantity x plus 5. Well, remember our little discussion on the first page. When I take some original expression, y equals, this is the x squared, the f of x, and I replace x with x minus h, right? The value of that h will dictate which way the original graph moves. Well, x plus 5, if you write it in that form x minus h, can you see how the value of h here is negative 5, right? That h mentioned on the previous page would be a negative number, right? Because x minus negative 5 would be x plus 5. And if you recall from, again, the previous page, when the value of that h is negative, the graph of the original will simply shift to the left, the absolute value of h units. So the graph will shift left. I'm going to make some tables. We'll see it in the tables as well before I make the graph. But the graph's going to shift to the left 5 units, right? The absolute value of h. Right? So keep that in mind. I'm going to put up the two graphs of y equals x squared and y equals x plus 5 squared, and you will indeed see that the graph of this new one is just the graph of the old one shifted left 5 units. All right. So before I get to that though, let's make some tables, right? Like I like to do with any function, or when I'm asked to make any graph, right? Let's make a table. Plot, find some ordered pairs that we're going to plot. So I have value of x, and my values of x, and then first I'm going to graph the y equals x squared. All right, so I'm going to do that in blue here. The blue, if you can't tell, this is a blue marker. There's no restriction on the value of x here, right? There aren't any denominators that could possibly be 0 or whatnot. No even roots. So I personally, and if you've probably seen me do this in other videos if you've been watching, I'm going to plug in the values -2 to +2, right? Just the integer values from -2 to 2. We'll get 5 points. And then here's how the output's calculated. The y coordinate's calculated. You take x squared. And then the third column, the actual point I'm going to be plotting. Alright, so when x is -2, y would be -2 squared or +4. Alright, so I'll be plotting the point -2, 4. When x is -1, output's -1 squared or just +1. So I have -1, comma 1. That point I'm going to plot. When x is 0, y is 0. So 0, 0. When x is 1, 1 squared is 1, y is 1. So 1, 1. And 2 squared is 4, so I'm plotting the point 2, 4. And I'll plot these 5 points, and again you're going to see that this y equals x squared when it pops up, it'll be this U shape, right, this parabola shape. So let me plot those locations. Now on my coordinate plane here, I'm going to have it set up so every square horizontally on the x-axis and every square vertically represents 1 unit. Right? Be consistent here. So the first point, -2 on the x, 2 left of center there, and +4 on the y. So we're talking this location. There's a point on the graph. -1 for the x, +1 for the y. There's another point. 0, 0 is our third point. 1, 1, our fourth point, and 2, 4, the fifth point. Okay, so I've got all these locations marked off, and again you hopefully see enough where you see a pattern forming and can draw the rest in. So I'm going to again do that in this blue here. Alright, so there's again going on that way forever, so the little arrow, and going up this way forever as well, and a little arrow. There's the graph of y equals x squared. Okay, so now in a different color. Alright, so maybe like a reddish here. I'm going to keep the same. Alright, I'm going to keep the same inputs here. And what we're going to do is I'm going to plug those in, extend the table a bit to this new function, this new rule, f of x or y equals the quantity x plus 5 squared. And then I'll have some ordered pairs, some points I'm going to plot after that, where you have the input x, output f of x, or the output the y coordinate. So these are the same x's over here. Right? So when x is negative 2, right, well, what's negative 2 plus 5? That's 3. You get 9, right? 3 squared is 9. So I'll be applying the point negative 2, 9. Negative 1, when I plug that in, negative 1 for x is negative 1, and then plus 5 is 4. 4 squared is 16. Alright, so I'm already seeing a bit of an issue here. Right? I don't really want to plot points with this high of outputs. But I'll plug in the other ones. When x is 0, I got 5 squared is 25. Right? 0 for input, 25 for output. When x is 1, 1 plus 5 is 6. 6 squared is 36. So you see these are getting pretty large. So I'm actually going to manipulate the table a bit. And you're going to see, hopefully when I change this table up a tad, we're going to see the shift of 5 units to the left that I said would happen. Right? And then when x is 2, 7 squared is 49, so you have 249. Again, I'm not really going to plot these points because the outputs get pretty large. So if I were to actually, I'm going to extend the table a bit. All right. And I'm going to extend the table upwards, and then we'll see our shift of 5 units. So let me draw this again. So again, here was our x column, and then our y equals x squared column, and then the ordered pairs for y equals x squared. And then for the f of x equals x plus 5 squared, the outputs of the second function, and then the ordered pairs for that second function. Alright, so I'm going to go backwards here. Plug in negative 3 for x, negative 4 for x, negative 5 for x, negative 6 for x, and you could do this all day long if you want. Now for y equals x squared, this would be 9, 16, 25, 36 for the outputs, right? So I have negative 6, 36, negative 5, 25, negative 4, 16, negative 3, 9, and so on, right? Lots of points. I can plot points all day long. Alright, now plugging these values into the x plus 5 squared. Negative 3 plus 5 is 2. When squared gives me 4. And then negative 4 plus 5 is 1, which squared is 1. Negative 5 plus 5 is 0. Squared is 0. Negative 6 plus 5 is negative 1, which when you square it is 1. And so on. So I'd have the point, negative 6, 1, negative 5, 0, negative 4, 1, and negative 3, 4. Alright. Now let me show you a little block here. Here's where you're going to see, in my table anyway, right? We'll see it in the graph more clearly. But here's where you see in the table a shift left 5. You see a pattern down this column that repeats over here. Look at this, this 1, 0, 1, 4. And then I'm seeing it again right up here. See all this, oh, sorry, that's bad. Right, so this 1 here corresponds to this 1 here. This 0 corresponds to that 0. This 1 corresponds to that 1. This 4 corresponds to that 4. And, I could keep going with this, right? If I even went further down, plugged in 3. 3 squared would be 9. This 9 would correspond to that 9. You see how all of these outputs from the original correspond to the same outputs in this new function, but look at how the inputs differ. With this output, for the y equals x squared, the input was negative 1. But then the same output for this function, y equals x plus 5 squared, has an input of negative 6. I went from input negative 1 to input negative 6 to get the same output. That's left 5 units on the x-axis. Right, from negative 1 to negative 6. Same thing here. This output of 0 for y equals x squared corresponded to an input of 0. But that same output of 0 for y equals x plus 5 squared corresponds to an input of -5. I went from input 0 to input -5. So you see I'm going -1 to -6, left 5. 0 to -5, left 5. 1 to -4, which is left 5. 2 to -3, which is left 5. For every single one of these, the ordered pairs, the points are just getting shifted to the left 5 units horizontally. All right, left 5 units on the x-axis. All right, so let me plot some of these points now. All right, so I'm going to again plot the red, some of the reds here. All right, so again, these points here, the f of x on the far right there, for the f of x equals x plus 5 squared, I'm going to plot these in red. So we have the -6, 1. There's -6 on the x, 1 on the y. There's that location. And -5, 0. Right, -5 on the x, 0 on the y. There's that location. -4, 1. There's that location. -3, 4. That location. And -7. You can test it out. When I plug in -7, -7 plus 5 is -2. Squared is +4. So I'd have -7, 4 as well. So do you see these 5 points I plotted for the blue graph are simply moved to the left 5 units, right? There's 0, 0 over to -5, 0. -1, 1 over to -6, 1. And you get a graph that's the same shape, right? The parabola shape does not change. It's just shifted to the left 5 units. All right, so the graph got moved this way. All right. So hopefully you saw it in the table here with the shift. Right, I saw a pattern in the outputs, and it's just simply the blue graph just simply got shifted up, left 5 when you look at the inputs, and you can very easily see it in the graph. Right. Now if you can avoid, I'm going to do this for the next example, you can avoid making these crazy tables if you know what's going on. Right? If you recognize, hey, x is replaced with x minus h, and then you know what h is, you can do the shift automatically. You can do the shift without having to make some crazy table. Now you can always do a table, don't get me wrong, right? You can always do a table whenever you're asked to make a graph. Plug in inputs, get outputs, plot points, and hopefully you plot enough to where you see a pattern, and then can fill in the rest of the graph. But this is kind of a shortcut using function transformations. If you recognize what transformation is going to occur, then just make that transformation happen. So that's what I'm going to do for my last example here. All right. So my last example, the same instructions. Right, we're going to be using the graph of y equals x squared. All right, so I'm going to plot y equals x squared first. All right, I'm going to do that in blue again. So now this time, for this graph, I'm going to have, just so we can see the shift better, I'm going to have 2 squares represent 1 unit. So these 2 squares, that's 1 left, and these 2 squares, that's 1 right. All right, so I'm going to have 2 squares on the horizontal represent 1 unit. All right, and then I'm going to have each square on the vertical represent 1. All right, so it might be a little weird, but I'm going to be consistent. All right, every 2 squares on the horizontal is 1 unit. So there's 2, there's 3, and so on. There's -2, there's -3, -4, +4. Okay, just again, and then every single unit on the vertical is 1 unit. So there's 1, 2, 3, 4, 5, etc. Okay, so just pay attention to the labeling. And of course 0 here. All right, so remember the graph of y equals x squared. Right? Remember, I'm going to start with that. Oops, start with we're starting with y equals x squared. Again, I'm graphing that in blue. We've already plotted points. So 0, 0, right? 1 squared is 1. 2 squared is 4. 3 squared is 9, but I'm not plotting that. Negative 1 squared is 1. Negative 2 squared is 4. Right, so there's a bunch of points, and plot my parabola. Right, it's this U-shaped thing, going like this. Okay, there's the graph of y equals x squared. All right. Now we're asked to graph here, by using function transformations, using these horizontal translations, the graph of f of x equals, x minus 1 squared. All right, so again, I can make tables, right? You can do the thing I did with the last example and make tables to see, what inputs give me what outputs. But look at what happened here. My original was x, right? X squared. And then what happens here is, x is replaced by the quantity x minus 1. All right, so remember back to that first page, talking about horizontal translations. X in my original expression, right, this f of x is like the x squared. The x in the original, all the x's in the original expression are replaced by x minus h, right, this quantity x minus 1. Right, so if you think of this as the x minus h, what is the value of h? Well, that's positive 1 this time, right? X minus 1, x minus h. H is 1, right? So the value of h is positive 1 here, meaning, look at my first page, if all the x's get replaced by x minus h and h is positive, then the graph of the expression I started with is just going to be shifted to the right that many units, that h units. So our graph, the graph of this new thing, x minus 1 squared, y equals x minus 1 squared, is going to be the blue graph, the graph of y equals x squared, shifted to the right 1 unit. Right? 1 unit. H is 1. Okay, so that should be easy to plot then, right? Just move all the points I see on the original graph to the right 1 unit. So this has 0, 0, right, the blue graph. Move that to the right 1 unit. So from 0, 0, the new graph has 1, 0. And I'll label it this time because we don't have a table. 1 input, 0 output. And check it out. When x is 1, 1 minus 1 is 0. 0 squared is 0. You'd have an output of 0. That point would indeed be on the graph. Okay, here is a point on the blue. 1, 1. Move that to the right 1. 1, 1. Shifted to the right 1 unit is at 2, 1. And again, I'll label it because we don't have a table up. 2, 1. And again, double check. Make sure it's actually on the graph of this new function f, right? If the input was 2, right, what's 2 minus 1? That's 1. And then squared is 1, so your output is 1. Right? Then this point here, negative 1, 1 on the blue graph, on the original. Move that to the right 1. From negative 1, 1 to the right 1 would be here on the y-axis, 0, 1. And again, I'll label it because there's no table, right? 0, 1. And again, double check. When x is 0, 0 minus 1 is negative 1. Negative 1 squared is positive 1. You indeed have the output of 1. All right, I'll just do these last two. The original graph had 2, 4, shifted to the right 1, because h is 1 here, you have 3, 4. And then the original graph had negative 2, 4, shifted to the right 1 would be at negative 1, 4. And again, it's the same shape, right? The shape of the parabola doesn't change. It just, is getting shifted to the right 1 when I replace x with x minus 1. Right, so I'll draw that in as best I can here. So same exact shape. And there's y equals, or f of x equals the quantity x minus 1 squared. All right. But yeah, so the key to take away from this is, what does it mean? When are you gonna see these horizontal translations, these moves left and right, these horizontal shifts? It's when you start with an expression, y equals some function of x, and in that expression all the x's are replaced by some x minus h. That's when you're going to see a horizontal shift. And if that value of h is positive, it's a shift to the right. And if I replace all the x's with x minus h's, and that h is negative, so it's really x plus something, right? Because if you subtract the negative, it's adding. So if I replace all the, if this was x plus 1 squared instead of x minus 1 squared, it would have shifted left 1 unit from the original. So that's the takeaway, right? The most important thing is on the front, on that first page I talked about, what does it mean for a function to undergo this horizontal translation or horizontal shift transformation. All right? Great. All right, as I like to say at the end of these videos, please do the best you can to learn the material on your own before you go looking for help. I find that people that take the time and the effort to learn something on their own tend to remember it better and remember it for longer, and they're more proud of it. So read the material, of course. Read through the author's examples. Perhaps even try to work out the solutions to an author's examples before you look at how the author did it. Then compare your work with the author's and see if you can learn from some mistakes there. Obviously do tons of exercises and practice problems. Look for solutions to those if they're made available to you to check your work and see how you're doing, keep track of your progress. And don't just give up on a problem after 1 or 2 attempts. Very often in mathematics there are several approaches that'll work for any particular problem. So if after several attempts you're still having trouble, I would suggest you actually go back and read the material again, maybe even a 3rd time, more slowly, more deliberately. Take good notes, because if you've been working on problems, as you should, there's a good chance that you'll have a better idea as to what the author wants from you in that particular section, what the author is asking of you. You'll see problems and maybe even see what does the author think is important from this material. So when you go back and read it again, or maybe even that 3rd time, you'll know better what to look out for in the reading. You'll know what the author deems important, so you'll be able to pick out some stuff that you probably weren't able to pick out the first time you read it. And it'll make working on the problems that much easier, hopefully. But if after that, if after several read-throughs of the material and several attempts at the problems, you're still having trouble, it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos online. There's tons of those too. Videos like this one, or plenty of other ones out there that are better than this one. I assure you they're out there, and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is the hardest thing for most people, stay positive. Believe in yourself and your abilities, even through your struggles and frustrations and mistakes and failures. Because it's in those moments when you're struggling and failing and making mistakes that you have the opportunity to learn the most, and also learn the most deeply. Because if you can persevere, if you can persist and make it through and actually learn how to fix those mistakes and work through your frustrations, you'll remember that material far better and far longer than someone who got it right the first time and never gave it a second thought and breezed through it. They'll have forgotten about how to do that material, how to work that problem, in a matter of weeks, whereas you'll probably have it stuck in your head till the end of the semester. There was an emotional connection to that material because you had to struggle so hard, and you'll be all the better for it. So stay persistent, keep practicing, stay positive, and don't give up. And I know you'll get it. And thank you very much for watching.